So welcome to our work period derivative class. We're starting off with a roll call. Yosuke just came in, which is great, so he's going to learn what we're doing today. We are recording our class live, and here to get us into the, spirit of math class, here's our funny. Ready? Wait.
I'm Amber.
Brad.
So
Haley.
funny.
Fender.
Brenda.
Sketch.
Shelly.
IQ.
Luann.
Joey. Mikey.
Vicky. Becky.
Jesse.
Darla.
Holly.
Noreen. Doreen.
And I'm
John C.
Okay, they're very excited about that. So now here's our math roll call. Jade is so excited as well, but we're going to start with Lloyd. Ready?
What?
You say I'm.
Wait.
Oh.
I gotta be the last one.
Okay, Emma, start.
Jane.
Me lost.
And I'm Miss Palmer. See, I like it, they're not, but I bet you'll appreciate that. So, waste of time. We're going to do one full 16-mark question here. The most important thing for this question, see, I knew you'll like this, is that you take out this last part of the question, okay? We're not going to do this part. In a test situation, you would see this as kind of a separate question on its own. So it says, for the function y equals cos of x squared, so cos squared x, determine the critical numbers, local maximum minimums, and POIs. So this is that big 16-mark question. Okay? Before we start, we're just going to go through the steps that we would do. So in a regular 16-mark question, the first thing I do, I find y prime. Right? This should be a bit of recall for us. The second thing I do is I'm going to find my critical numbers. The third thing, I'm going to simplify, and this is where it's a little bit different, my y prime, bless you, and then find my y double prime. So again, that's the thing that's a little bit different. Step 4, we are going to check the concavity to find if it's a local max or a local min at that point. The last step, we're going to do our POIs, same as usual, and the 6th step, we're going to sketch. Bless you again, 3 times the charm. So, going through these, we start with our y, and I will go through and I will label them, the numbers, just to kind of keep us on track. Yeah?
When housing the square brackets 0, 2 pi, are those our endpoints we
Exactly.
test?
That's my interval. So that's my endpoint for sure.
Okay.
Now, it's a little bit different in the way that we check intervals. We don't need to look for absolute max and mins, but we'll take that into account. Okay. So for first step, find y prime. Well, this is, remember, y, if I were to rewrite it, is the cos of x all squared. So my y prime, this would be 2 cos of x times the negative sine x. And I'm just going to rewrite this to be negative 2 sine x cos x. Remember, it doesn't matter which order you have your sine and cos. I generally write sine first and then cos after. Vincent, do we have stuff? Yeah? Cool. Yes, please do. Actually, they were in the classroom right here. Merry Christmas. Okay. So, first step, complete. Now, if I'm looking at this, sine of x and cos of x, is my function defined everywhere? Think really, really, really hard about the unit circle.
No.
No, okay. Where is it defined?
At tan when sine is over cos.
Okay, for sure, yeah, so that ratio still has to be true. Specifically, though, each of these functions, sine and cos, remember, on a graph, they go from positive 1 to negative 1, right? But not that graph. So I need to have my function in there. Here we don't generally talk as much about whether or not y prime is defined, just because I know for my sinusoidal functions it's going to vary between negative 1 and positive 1. Step 2. For my critical numbers, we set y prime equal to 0. So same as before. I get 0 is equal to negative 2 sine x cos of x, which really means 2 different things. And this is where it gets to be very important. I'm going to start to kind of color code the work just so you can see both sides of it. So I get one option that the sine of x is 0. Color coding, I get my other option, let's go with orange. cos of x is equal to 0. Now, recalling that my original sine function starts off at 0, right? The sine function starts at 0 versus cosine starts at the top. So I'm going to say that sine x equals 0 when, going back to pink, x is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. But I'm stopping at 2 pi because, as Jane said, that's the interval. I don't care what happens on the other side of 2 pi. So those are the 3 options that my function sine of x is equal to 0. How do we feel that? Seems okay? All right. Then I look when can...
My question, where did that pi come from?
Pardon, sorry?
Where did pi circle?
Pi? Yeah, so that's your unit circle. So remember, and I will distribute if you like. These are blank unit circles, although not very helpful right now because I don't have filled in ones to give you. If you want one, just ask Abilene.
I'm in the middle of it right now.
And I solve for the cos of x to be 0.
No.
That's the problem.
Everyone's got one?
Like this is like because
So pi is
Jane hasn't done trig and advanced functions yet, so she
Okay,
just
let's
doesn't
look.
understand why.
Thanks for calling me out.
No,
What?
not at all.
What?
He said that pi is equal to
No,
what,
like
90 degrees?
if you have it-
What? Since what? What? What?
Okay.
if you haven't, if you didn't do trig, if you didn't do advanced functions, you wouldn't know. Because that's what we did.
Okay, so we're going to look at this here. If I look, this is my sine function. Okay, so everyone's looking up on the screen right now. My sine function.
But not the, we've never touched pi last year with the unit circle. With like it being pi over something. Or
No, you do the advanced
Are you
functions.
gonna fill it in?
we didn't touch right now.
Not right now.
I'm
You're
always
gonna,
going to
you're
go
gonna,
to
you're gonna do it.
Okay, so up front, please. This is my sine function. It starts at 0. The time that sine of x will be 0 is at 0, pi, and 2 pi. Remember, 2 pi is the period it takes to do a full cycle. So when you talk about the unit circle, you would go half a pi, full pi, all the way around to 2 pi, right? So that's where you would have seen it before. So on the unit circle, this is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, right? As you go around the circle. So biggest thing to know, the cosine of the function is 0 at 0, pi, and 2 pi. So there are 3 places. Now, if I'm looking for the cos function, which I'm hoping if I click on this image, what is that? I can't read upside down.
But it would be on its half points, right? Because it's like the shifty thing.
Yeah, then I look here. So this is my cos, the blue. When is it 0? Pi over 2, 3 pi over 2, and intervals of that. Okay, so that's where I get those 2 values. Looking back here, I now have kind of 6 options. Sine of x is 0 at 0, pi or 2 pi, and I now have cos of x to be 0 at pi over 2 and 3 pi over 2. Remember that these are critical numbers. That means they are either maximums or minimums. What will happen is either all of the pink will all be maximums or all of the pink will be minimums, meaning that the opposite will be true of the orange. All the oranges will be maxes or minimums based on the other one. Now, how do we determine this? We go to step number 3 and we simplify y prime first and then find y double prime. So I can check the concavity there. It's the easiest way. So step number 3. I'm going to use a double angle identity. Remember how we said that you don't necessarily have to use identities in this calculus unit, but it makes it way easier to do the derivative. Remember, y prime is -2 sine of x cos of x. Using this identity, I can simplify my y prime. I can now say y prime is just regular negative sine of 2x. See how much easier it's going to be to do the derivative of that instead of doing product rule? You can still do product rule if you don't use that double angle identity, to find your y double prime. It'll just be a lot more difficult, and factoring it will be a bit harder. Okay, so I find y double prime, take the derivative. The derivative of sine x is cos x, so this becomes negative cos of 2x times 2, so negative 2 cos of 2x. So this is my concavity. Step 4 is when I'm analyzing my concavity, and I have it set up like this for a reason. I want to know the concavity at all of those pink points and all of the orange points. So sticking with pink, I'm using my concavity.
Where did cos x go? For the third one.
Yep, so this part here, using the double angle identity, I can go from this term here and turn it into this term. So that's with the use of an identity. So the sine of 2x, I can write that here. Sine of 2x is the same thing as 2 sine x cos x. So that's that double angle identity that I'm using. That's how I changed it from 2 sine x cos x to negative sine 2x. So what I want to do now is I want to check my concavity at all of those different places. I'm going to check y double prime at x is 0, at x is pi, and notice I'm kind of going vertically here for a reason, so just bear with me. Y double prime. Okay, and we'll test the other ones out in a second. Okay. So as I test the concavity here, notice into y double prime, I'm actually going to write it, just so you can kind of see what's happening. 2 cos of 0. Well, the cos of 0 is 1 times negative 2, which means my y double prime is negative. It's sad, right? So is this a maximum or a minimum at this point? Yeah, I have a max. Let's check again at my other pink points. Y double prime is negative 2 cos of pi, and when I evaluate, my y double prime will be, again, less than 0. It's sad, it's negative, I have a max. I'll evaluate here, y double prime is negative 2 cos of 2 pi, and surprise, surprise, my y double prime is negative. So all of my pink values give me local maximums. What do you think all of your orange points are going to give you? Perfect. So on an assessment, you should be able to kind of think this through. Once you know what set 1 is, you should be able to determine the set for the other. So I'm going to check my y double prime at x is equal to pi over 2. And I'm going to check my y double prime at x is equal to 3 pi over 2. Negative 2 cos of pi over 2. We're okay? We'll be positive here. So I get a minimum. You do need to show that, but really what you're doing is you're just kind of running through the procedure because you know what the outcome will be. But you do need to show all 5. There might not be 5 depending on your interval. Like if I give you a very small interval, it might just be 2, which is nice. But you can see this pattern would continue, so on. Okay. So we got through that. We're happy. I have to determine my P.O.Is. The P.O.Is are, I will just let you know now, the worst part. Okay? In my personal opinion. If you find you are running out of room right now, as I find on my page, I will be using probably the second part here to do a graph, and I'll be able to fit my y double prime there. Yes. So which part, Lloyd?
Is it 3 pi over 2?
Yep, 3 pi over 2, comma 0. So we're just going to go with black marker here just to kind of show it's the very last step. I'm going to check on my POIs. I already have my y double prime. Negative 2 cos of 2x. Right, I've already solved for that. And I set it equal to 0. Right, for possible POI. Set y prime, double prime equal to 0. Negative 2 cos of 2x. So then I get here. This is where you must think a little bit differently than something you would have seen before. So this is where I'm going to think, when is the cos of something equal to 0? Like, pretend you're putting your finger over the 2x. When is the cos of something equal to 0?
0.
Okay, so at 0, remember that's 1. You're thinking of a sine function. So when is my cosine function equal to 0? 1. Pi over 2, 3 pi over 2. Remember my solutions from the last one. Here, when is the cos of 0, cos of something equal to 0 at pi over 2 and 3 pi over 2. Right? So that's what I'm thinking at this point. Here you would get x equals pi over 2 or 3 pi over 2, right, in this interval. But that's what x is. Now this is 2x. So this is kind of just a little weird. I'm going to say 2x is pi over 2. And 2x is 3 pi over 2. So see how I'm taking what it was, and I'll just zoom in a little bit so it's a little less crazy looking. I say, when is the cos of something equal to 0? Hey, that happens at pi over 2 and 3 pi over 2. But I'm really dealing with the cos of 2x. So I'm going to take these values, and essentially what I'm going to do is I'm going to divide them by 2. This is twice as big as it should be for this specific function. So I'll get x as pi over 4 and 3 pi over 4. So it's not that that is necessarily overly difficult to get that dividing by 2 there, but just kind of understand why that's happening. And remember, I want the specific points where this is happening, pi over 4, and into the original equation, 3 pi over 4.
Wait, actually, 3 pi over 4, I thought you cancel out the 2.
3 pi over 4, so it's 3 halves dividing by 2, so my 2's are really multiplying.
Wait, aren't you doing times 2 to get rid of the 2?
I'm dividing by 2, because there already is a 2,
Oh.
so I'm dividing by 2 to get rid of it on both sides. So 2x divided by 2.
How's your 2 already there?
The 2x, like this part here, Lloyd, comes from this part. Because my y double prime was the cos of 2x. So I'm trying to take that into account now. So into my original function, the cos squared of x, you plug in pi over 4, and you get a half. You plug in 3 pi over 4, and hey, you get a half. Yes, into the original, always back into the original equation. The cos of x all squared. Now you have all of your work. All we have to do now is create a picture. These are very challenging problems, and you are being troopers. The pi over 4 will generally be your base scale there, but we'll talk a little bit more in the new year about how to determine your scale. So I'm going to go back and I'm going to plot my points. I like to plot all of my maximums first, then I go back and plot my minimums, then the POIs, and then you're done. So my maximums occur at 0 and 1, pi and 1, and 2 pi and 1. So 0, 1, it's up here. Then we said at pi, 1, and 2 pi. And then the last part is those POIs that I just determined at pi over 4, a half, 3 pi over 4, and a half. I only have 2 POIs. Does that make sense? I should probably have more. Right? As I start to kind of fill in the blanks, right? The POI, it changes, it's going to go up. It's a beautiful graph. It's a Christmassy graph. Well, I know I'm going to have another POI here and here. Because remember, it's every pi cycle. So really, if I took this point from above and I add a pi on, I'm going to get to 5 pi over 4. Right? If I plus pi, I'm going to get to 7 pi over 4, comma 1/2. So I kind of just always want to extend these to my interval. Right? Add a pi to get those last two.
Do you have to state that, or can you just?
You can just have it there graphically. Now, if it's asking you specifically to state all of the POIs in the interval from 0 to 2 pi, then you do want to state it explicitly. And then you have your graph. This is the graph of cos squared x, I believe. Yes.